Welcome to one and all present here. We are team Aaron Mix Clever here with the problem statement ID SIH25190 with the problem statement title AI driven frequency response analysis for transformer diagnostics via unified multi format software. Our theme is clean and green technology and our PS category is software and our team ID is 81228. Let's see the problem statement and solution for our approach. So the problems that we are facing for predictive transfer fault detection system are FRA helps to detect transfer faults like core displacement, winding deformation, and insulation issues. Interpreting FRA signatures is complex and needs expert knowledge. No standard data format across different FRA equipment vendors. Manual analysis causes delays, inefficiency, and inconsistent decision. There is a need for an AI-based platform to automate analysis and give accurate and actionable fault insights. The solution that we have proposed is AI-based fault detection, no need for expert judgment, standardized data handling, faster and consistent diagnosis, actionable insights, and guidance. Let's see the technical approach of our problem statement. So the technical approach that we have developed for our prototype is the layer, the technology, and the purpose. Let's see what's there in the front end. So front end we are using React. We are using React and design, providing the engineers with modern and easy to use interface. So this is generally we are using for dashboard UI and test visualization. Coming to the back end, we are using Fast API, which is Python, which helps us to file handle and also inference API. Next, coming to the modern layer, we have developed the modern layer with for training the AI model PyTorch, and it is exported to ONNX for fast inference and fault classification model the purpose. So next, coming to AI runtime, we are using Torch and ONNX runtime so to train the model in a productive way. Now let's see the prototype of our model. Earlier we saw the problem statement, its solution, and technical approach. Now we must see how the technical approach is being implemented in our prototype. The prototype that we have developed is FRA diagnostic system. So what does FRA stands for? FRA stands for frequency response analysis diagnostic system. So here, to know how the model or this web application is developing is working, we must know how the file is being uploaded and what is the next step it's going to happen. So for that we must go to new step. So the button new step has to be clicked first, then we must upload the FRA test file. So after uploading the FRA test file, we can see the test analysis. So here's the dashboard that we are going to see. First comes the test metadata. The test metadata gives the information what transformer it is, the windings, the number of windings is 56 here, the test date, and the operator who's taking care of that transformer. Next, we can see the data preview. The data preview is the recent data of the frequency, magnitude, phase. The frequency is given in hertz, magnitude is given in dB, and phase also is being given here. We can see the test data which is being here. Next, coming to the frequency response analysis, we can see it is given in both log and as well as linear. The graph is being marked against magnitude and frequency, and we can see in both the variations. So even we can see the phase also in this. Next, we can also download the chart and use it for the further future uses. Next, coming to the run analysis. The run analysis shows the detect or defect in the transformer. So next, coming to the condition of the transformer, then the radial deformation and core grounding. Since the color green indicates it's very safe, in axial displacement we can see the probability of 56.5% is being something there is a problem. So the primary diagnosis is analysis indicates axial displacement with 56.5% probability. This result shows more confidence that some problem is being detected in such way. So we can see what's the solution approach. So the recommended action is inspect axial clamping and spaces, verifying winding to core and clearances. So the medium priority is repeat the frequency response analysis check and leakage reactance. So in this case, one can accept the diagnosis, or he can just tell this diagnosis is wrong and he can just give the what problem he has and he can do. Let's see how to do that also. So in this, we're going to accept the diagnosis that we can accept, and we can just do the changes over there. Else we can just go for the reject and edit option, where we can just choose what fault it is, and then go for the additional comments also, and we can just see what's happening there. So this is a final report or final prototype of our project, and we can also export the details of that particular transformer, and we can just store it in our database. So, and this is the dashboard. So here we can see the recent test. We can see the transformer ID, the vendor is Omicron, the winding is 56, the data, the operator, the status, fault, probability, and actions that we have taken. So this is the prototype that we have developed, and I thank SIS for giving us this wonderful opportunity to showcase our talents through all the software and hardware projects. Thank you so much.